Hi there, in this lesson we're going to look at inequalities and then solving inequations. Now hopefully you've watched the video lessons or understand how to solve normal equations, and then this will make more sense to you. So we've been dealing a lot with this equal to symbol, which is just an equal sign that everybody's comfortable with, but in maths you can compare numeric values by using other symbols like greater than or less than. For example, 5 is greater than 3, of course it is, and 3 is less than 5. But we've got math symbols to represent these words, and we're going to have a look at them now. So the greater than symbol is a wee arrow, and I always think of a number line that's pointing towards the bigger numbers. If you look at this number line here, this arrow points to the larger numbers, which makes sense, it's greater than. So less than is the opposite. So if you're thinking about less than, it's pointing to the smaller numbers, which points in that direction. And then you've got a greater than or equal to. It's just kind of similar to the greater than sign, but it's got a wee line underneath, kind of symbolising an equal sign, a squint equal sign, but it's still an equal sign. And then you've got less than or equal to. Now, when you're dealing with these things, you can insert them in between numbers. So, for example, we can say that 6 is less than 10, so you would insert it there, and that would be a correct mathematical statement. 4 is bigger than 2 or greater than 2, you would do that. 5 is less than 6. And 0 is bigger than -1. Now again, what you'll see here, note that the signs always point to the smaller side in every case here. Right, but our job is really to look at inequations. They can be called inequalities as well, but I quite like to call them inequations because they're in the equations topic. So this is an important idea in equations or inequalities. When instead of having a balanced scale when you're solving these things, like we did in the equations section, like one side's equal to the other, they're not. The scales are unbalanced, so one side's bigger than the other, basically. Now, a common mistake here is to think that x is greater than 12 because it's higher up, but the heavier one is the bigger one, isn't it? It's the one that's pushing down here. So what we're saying is there's basically that x is less than 12. Because it's not as heavy. 12 is heavier than x, and that's why this side's pushing down. Now, if you have the scales on the opposite side, we've still got 12 and x. You can switch things around when you're writing it down mathematically, but we've got to be very careful here. And we'll talk about this more in detail later. But if you're switching around, now 12 is the heavier side on this side. So we're saying that 12 is greater than x. Okay, so when you switch the inequalities or equations round about, you've got to switch the sign to make sense of it. If you're putting the 12 on this side, that's fine. X is smaller than 12, but that means 12 is bigger than x. So if you switch the sides round about, you must switch the signs. And again, we'll deal with that a wee bit later. The same idea would be something like this. So if you've got, well, 12's the heavier one, isn't it? So it's the one further down. So 12 is greater than x plus 2. But if you switch things round, which sometimes you want to do, you've got to switch the inequality sign. X plus 2 is smaller than 12. Now, dealing with inequalities is very similar to solving equations. So if I'm trying to solve this here, then what I can do is the same idea. Whatever I do to one side, I must do to the other side to keep it the same. So if I take 2 off of this side here to get x on its own, and I take 2 off of this side, then I'm left with x here, and I'm down to 10 over here. So basically what we're saying, and we keep the inequality sign the same, we're saying that x has got to be smaller than 10 to make this work. Well, let's have a look at that idea. Well, 10 plus 2 would make 12, and it wouldn't be less than 12, so 10 doesn't work, and we're saying here that x needs to be smaller than 10. So you can try 9. 9 plus 2 is 11, that's smaller than 12. You could try 8. 8 plus 2 is 10, smaller than 12. So any number less than 10, you could list them out, 9, 8, 7, 6 if I asked. Any number smaller than 10 makes this work, and that's how you solve an inequality. It's very, very similar to equation work. If you look at the equivalent equation work, you add 4 to both sides here, and this add 4 to both sides, just keep the sign the same. And a kind of more two-step equation, more complicated one, take 7 off both sides and divide by 2, An inequality with a greater than or equal sign, take 7 off and divide by 2, just keep the sign the same. So, let's have a look at some examples of those, and that will finish the lesson off. Right, so the first one, what you want to do here for trying to solve this using the kind of balancing technique. So what we want to do is we want to get the x in its own, and we do that by taking away the 3 from both sides. So that leaves us with x, the sign stays the same, and there's your answer. So x needs to be bigger than 3. Any number bigger than 3 would make that statement correct. For example, 4. 4 plus 3 is 7, and that's greater than 6. Great. With a takeaway, same idea. Add 5 to both sides. That's going to leave you with x. That's going to give you 14. Keep the sign the same. And even with a greater than or equal to sign or a less than or equal to sign, just do the same thing. Take away 2 from both sides, as normal. That leaves you with an x. Get greater than or equal to -2. Okay, let's look at ones where you've got multiple values of x. So we've got 2x is greater than 4. Well, what would you normally do? We'd divide both sides by 2. So you've got x is greater than 4. Next one, we'd normally divide both sides by 5. Do the same thing, divide by 5. So x is less than or equal to 40 divided by 5 is 8. Now, this is quite an interesting one because it's kind of the wrong way around. Okay, so because it's the wrong way around, I don't really like it that way around, so I'm going to switch it round about. So what I've got to be careful here is, we talked about that before, I've got to switch the inequality sign round about, and then do my divide by 3. You can see it appearing there. And that's x is less than 3. So that relates back to what we were talking about before. If the x is on the wrong side, you kind of want it over here, switch it round about, but switch the inequality sign. Right, let's do a few two-step to finish off. Okay, so what we're going to do first is add the 1 to both sides. Then you're going to get 4x is greater than 20. We would divide both sides by 4 at this point. This is going to give you x greater than 5. And you can see that the inequality sign just stays the same. Take away 4 from both sides here. And that's going to give us 3x is less than 15. Divide by 3, sorry, less than or equal to 15. Divide by 3, and you've got x is less than or equal to 5. And the last one, add 12 to both sides. And you get 6x is less than 12. Divide by 6 to finish. For a nice finish, x is less than 2. So very, very similar to equation techniques. Just be careful with writing the same inequality sign all the way down. I have seen people writing equals right at the end. That would be wrong. And watch out for this. If you have to switch sides, make sure you switch the inequality sign.